Hey everyone, my name is Scott, and today we're going to solve the maximum depth of an n-ary tree problem on LeetCode. Here's the problem definition. Given an n-ary tree, find its maximum depth, and they define the maximum depth as being the number of nodes along the longest path from the root down to the farthest leaf node. So here's what they call a 3-ary tree, where you have up to 3 children per node. And the return for max depth is 3, and you can see that 1 starting here at the root, 1 node, 2 node, 3 nodes, or alternatively 1 node, 2 node, 3 nodes. So there's 3 nodes on the longest path from the root down to the farthest leaf. And down here they give us the definition for what a node is. It has a value field, which for this problem we don't need at all. A list of nodes, which is the children, and then it just has the constructor here, which we don't need to use. So whenever you're given a problem that involves trees of any kind, recursion is usually a really good idea to start thinking recursively. And you can say, well, I can break the tree apart, recursively solve different parts of the tree, and then put the problem back together. So let's think recursively. So let's think of the base case. So what happens if the root is null? Well, obviously if the root is null, then there's no nodes in this tree at all. We'll just return 0. There's no nodes. We have no max depth. And then our next base case would be, what happens if root has no children? Well, in this case, our longest path is just the root node, since it's the only node in the tree. So we'll return 1, having just 1 node in the longest path. So once we get down here, the root is not null, and it has children. It has children. Those children might be null, but there at least are some children in its children list. So let's recursively solve each child node and then add 1 to it. And we find the max depth amongst the children, we add 1, then we have the max depth all the way up to the root. Save this max child depth integer, which we'll set at 0, because if it's 0, then all the child nodes could be null, but then we'll just have a depth of 0, and we'll just have a depth of 1 for our root. And then we're going to loop through the children. And for each child, what we need to do is recursively solve for that child. So we'll store current depth, set that equal to maximum depth from the child node. And we're just going to see if the current depth is greater than the max child depth that we're keeping track of. If it is, we'll update it. And then at the end of the loop, all we have to do is return the max child depth plus 1, because we need to add back in the root node. And that should be it. Let's see if we have any syntax problems here. Looks good. Alright, accepted solution. Sweet. So again, tree problems, it's always helpful to think recursively and say, well, I'm given this tree, I can break this problem down. So if you look at this problem here, what did we do? We took the node away, and then we went through each child node and said, what's the max depth from here? What's the max depth from here? What's the max depth from here? And what did those recursive calls return? So it said, well, here, for this subtree of these guys, the max depth is 2, right? 1, 2, or 1, 2. And then for this subtree here, it said, well, the max depth is just 1. And then for this subtree, the max depth is 1 as well. So for each of our recursive calls, we got a max depth of 2, 1, and 1. So we took the maximum of those, which was 2, and then just added 1 to get 3 back. So that's it for this video.